today's event. I am here with Dr. Rod Russell, a professor of virology and immunology at Memorial's Faculty of Medicine, and he will be discussing where we've been, where we are, and where we're going with COVID-19. My colleague Sarah Bartlett is in the background helping us with the Q&A in case we get inundated with questions. I know those of you attending can't see who else is in the room for the event, but we have a full house. We had over 200 registrants for today's event, and we've got people joining every second, so we are delighted that you have chosen to spend some time with us today. We are going to begin today's event with a land acknowledgement. We acknowledge that the lands on which Memorial University's campuses are situated are in the traditional territories of diverse Indigenous groups, and we acknowledge with respect the histories and cultures of the Beothuk, Mi'kmaq, Innu, and Inuit of this province. We encourage everyone to reflect on these lands from where you are located and the Indigenous peoples for whom these lands are traditional territory. At the Office of Alumni Engagement, we are focused on offering many ways for you to connect with Memorial from anywhere in the province, the country, and the world. And we're working diligently to foster opportunities for alumni and friends to celebrate their connections with Memorial and with each other. MUNalum 101 was born out of the need to reach out to alumni during the first few months of the pandemic. It has since evolved to become a cornerstone of our alumni engagement activities, offering the latest information on key topics from Memorial University's own experts. Embarking on new and exciting ways to build relationships within our Memorial community is vital to our evolution as an institution. Please consider getting involved with our programming. You can be a mentor with 10,000 Coffees, discover opportunities to meet up with expats through Global NL, and our online book club Coastlines features a stellar selection of Newfoundland and Labrador authors, most of whom are Memorial alumni. And you can find more details on our website, www.mun.ca/alumni. Just a few housekeeping issues for today. A brief Q&A will follow Dr. Russell's presentation. As I mentioned earlier, my colleague Sarah Bartlett will be helping me monitor the Q&A and the chat functions, which you will find at the bottom right-hand side of your screen. So please try to keep your questions short, and I encourage you to post questions as soon as possible. Don't leave them to the last minute, as I think that we are going to have a lot of questions today. As attendees, you might have discovered already that you're unable to unmute your microphone or turn on your video, but you can communicate with other attendees through the chat. And you can also enable closed captioning at the bottom left-hand side of your screen. You also have the option to customize your view of this presentation if you click on the dots at the top right of your screen. I think it's called Layout. We are streaming live, but this session is also being recorded, and all those who registered will receive a link to the event and a follow-up email. It is my very great pleasure to officially introduce our special guest today. Dr. Rod Russell is a professor of molecular virology and viral immunology within the Division of Biomedical Sciences, Faculty of Medicine at Memorial University of Newfoundland and Labrador, and he holds cross appointments in the Department of Biochemistry and the School of Pharmacy. A proud Memorial alumnus, he obtained his bachelor's degree in biochemistry and a master's degree in medicine studying HIV under the supervision of Dr. Michael Grant, and then did a PhD at McGill University with Drs. Mark Weinberg and Chen Lang in the field of HIV research. His team is currently funded by the Canadian Institutes for Health Research. He is the president of the Canadian Society for Virology and a member of the Canadian Network on Hepatitis C. Dr. Russell sits on editorial boards for Pathogens and Immunity, Frontiers in Immunology, Frontiers in Microbiology and Viruses, and he is the editor-in-chief of Viral Immunology. He was recently awarded the MUN class of 2022 Silver Orator Teaching Award. Dr. Russell has been a great demand as a speaker in the media since the pandemic has begun, and has done over 150 interviews online, on radio, and in television. And we are thrilled that he's joined us here today. So I'm going to turn the presenter duties over to Dr. Russell, and he is going to begin his presentation.
Okay, can you see my slides? Can we see the slides? Yes, okay, great. So thank you for that wonderful introduction, and it's my pleasure to have an opportunity to give this talk here today. So I'll get right into it. The first thing I'll say is that the original program that went out listed me as having an MD in 2000, and I thought that was interesting because I don't have an MD, of course. I have an M.Sc in 2000 from MUN, and I thought of Joey Tribbiani from Friends, who used to be a doctor on Days of Our Lives. So like Joey, I'm not a doctor. I just play one on TV, and there's me. There's my daughters hugging daddy on TV. So I've used this slide all through the pandemic, and I'm still using it because we're still in a pandemic. So nothing in life is to be feared. It is only to be understood. Now it's the time to understand more so that we may fear less. And I know that by heart by now, of course. That's from Marie Curie, who was one of the original women in science. So this is a slide that I have presented many times in my teaching over the years. And in in 2019, on November 20th, 25th, I gave this presentation, or an emerging viruses lecture, to medical students. And this was the list of the most well-known emerging viruses at the time. And I always say at the end of that lecture, whichever class I'm giving it in, that these are not the viruses we need to worry about, because the real threats are the ones that aren't on this list, the ones that are out there and we don't know are coming. And it's I find it very daunting now to think that on November 25th in 2019, SARS-CoV-2 was already circulating. So when I said the ones we need to worry about are the ones that aren't on the list, that we don't know about, there was already the next pandemic virus circulating in China and about to come into all of our worlds. So by now, of course, we know lots about this virus. It's SARS-CoV-2. And this is a slide borrowed from a colleague of mine, Dr. Susan Weiss, who was studying coronaviruses before everybody started studying coronaviruses, we'll say. We know now that this virus comes from the bats. We thought there was an intermediate species, but that turned out not to be true. And this happens more often than we realize. There's zoonotic events all the time happening. Sometimes they cause a single person to get infected. Sometimes they cause a few. But the point is, if a virus has pandemic potential, it can get from its natural host into the human population and cause what we've lived through in the last few years. What I find interesting with this slide is that in March of 2020, or February of 2020, when Dr. Weiss presented this slide, one of her questions at the time was, she wondered to what extent this virus might get out of China. And most of the world was in lockdown within weeks after she asked that question. That was in Barcelona in February of 2020. And the virus was probably already in Barcelona when she was giving that presentation. My first thoughts on this, this was a coronavirus. This was a common cold. Most people hadn't heard of rhinoviruses, coronavirus, respiratory syncytial viruses, parainfluenza, but these are your common colds, right? These are the viruses that infect us every year, and usually, are not too serious. So most of us thought, okay, it's a coronavirus; it shouldn't be a big problem. And if you're worried, we were almost being sarcastic about it. If you're worried about coronavirus or respiratory viruses, go and get your flu shot, because flu is always an issue. But then it hit New York, and I realized two things. It's coming. It was coming here, and it was infecting young people who had intact immune systems and making them very sick. So it was at that point that I realized, okay, this is going to get to all of us. It's what was different, of course, is I was wrong, because this virus had a superpower. It could spread really fast. So you pair that with the fact that humans had almost no immunity against this virus, no pre-existing immunity, um, that resulted in basically we were just an open field for that virus to infect. We were actually lucky that it wasn't worse than it is, right? Um, and that's sort of the reason I think that that this virus was able to cause a pandemic because it doesn't kill at high rates. So if we look at other viruses such as the original SARS, the case fatality rate was 10%. MERS, a related coronavirus, it has a case fatality rate of 35%. So 35% of people who get infected die from that virus. Ebola is 50 to 90%, depending on where it is and what the health care system is like where these outbreaks happen. Now, if you look at the Spanish flu, which was the last pandemic virus, 2.5% of the people who got infected died, which was around where we were when this pandemic started. So that might indicate that, excuse me, it's the viruses that spread fast but don't actually kill aggressively that can set up a pandemic. So if we look at the human coronavirus timeline, we have the common cold coronaviruses OC43 and 229E were discovered first, and then the first SARS, the human SARS, was around 2002. And again, right, it didn't kill that many people, so it didn't cause a pandemic. Partly because it made people really sick. Everyone knew they had it, crazy high fevers, and very clear symptoms. Other common cold coronaviruses, your HKU1 and your NL63. Then MERS popped up in around 2012, but same thing, not that many people got infected, so we didn't see, any sort of pandemic potential with that virus. And now here we are in 2019, we had SARS-CoV-2, COVID-19. By now, we have 6.6 million reported deaths. The case fatality rate is going down, partly because of the vaccines, but also because of the fact that we're building up natural immunity. If you compare that to the influenza, for example, about 250 to 500,000 people die a year of flu, whereas we're more like 2 or 3 million people a year right now with SARS-CoV-2. Hopefully that will keep going down for a year. I mean. So just to explain the variants a little bit, we've come up with this naming system. By now you've all heard of these variants of concern, but there's other lists, we'll say. So there's variants under monitoring, and these are variants that we know of, but they haven't reached high prevalence yet. They're not dominating. Um, Variants of interest are a little bit higher prevalence, or they seem to have a characteristic such as spreading faster or making people sicker that makes them one to watch, we'll say. And then the actual variants of concern. So once we see a certain level of prevalence, then a variant can be classified as a variant of concern. And we've known this Greek alphabet now that we use, alpha, beta, gamma, delta, omicron. Alpha has now been de-escalated. And all of these different variants have had different, what I call superpowers, or the phenotype, or what they actually look like as an infection. And basically, they all have mutations, and we've heard all about these different mutations now over the last couple of years. And basically, it's these superpowers are transmissibility, so the ability of the variant to spread. Some spread faster than others, and the ability of the virus to get around antibody bonding. So the immune system, our immune response, the antibodies that we make in response to the vaccines or in response to infection. At some point, these variants started to mutate the pink protein on the outside here so that the antibodies couldn't bind as well. So it all happens here. This ability to bind better to the cell, to get in faster, that helps the virus spread, and the ability to keep antibodies from binding to it to block the virus from getting into cells. So these are sort of the phenotypes. And then, of course, we had Omicron. So at the beginning of this year, we saw the fastest one yet, which has the highest transmissibility. It's also very effective at breaking through infection. So we saw lots of vaccine breakthrough. And luckily, it causes milder infection. So very early, it was thought to be a milder infection, and it clearly is in most. And I have to qualify that because we're still seeing lots of people dying from this infection. But in relatively healthy individuals, most people have a milder infection than we've seen with Delta or anything before that. And this is likely due to a couple of things, right? The virus itself is not as pathogenic, but also we have the impact of vaccines now in most places. So we've got a bit of a head start in our fight against the virus. That one had a long list. Some of these variants had a few mutations, but this is the list of mutations here in just in the spike protein. And when I looked at the list of mutations, I realized that it was almost as if Omicron had taken superpowers from all the other variants, because it had, if you look at these mutations, these are mutations that Omicron had in common with the other variants of concern. So our famous 501Y, the E484K, these are, if you were looking at what these mutations do and how these variants were defined, these were sort of key mutations, but Omicron had a lot of them. If we compared Omicron to Delta, the risk of hospitalization was half that of Delta. The duration of hospitalization was 3 days less than with Delta. The risk of going to the ICU was 74% lower, and the risk of dying from Omicron infection was 91% less than it was with Delta. So as time went on, we saw that it clearly was a milder virus, but again, not for everybody, right? Which is, we still are in a way. Here's a very sort of recent look at the different different subvariants. So by now it's all Omicron. Over 99% of the virus that's being sequenced around the world is Omicron or some variant or version of it. So we have our BA2, BA4, BA5. These are the ones we've heard of. These are the popular ones right now, and they have reached variant of concern status. The big thing with them is they all affect how the immune system can see them. So we know that vaccination with the original vaccines don't protect you that well from infection with these variants because they've picked up so many mutations now that the antibodies we made are not binding as well to these variants. And luckily, most of them have reduced or no increase in severity of disease. So then we also have all these others. So if you're paying attention, if you're watching these things, we have the BA 2.75, now the BA 2.75.2, the BQ 1.1. These couples shown here in yellow are probably the two most interesting and most concerned ones right now. They're still under monitoring. They haven't even reached variant of interest status, but we know that they're more antibody evasive than BA5. So they're even better at breaking through the immunity that we get from the vaccines or from previous infection. So we're keeping an eye on them. So to talk a little bit about the vaccines now, basically just to give you a little bit of an education on the immune system for those of you who haven't studied immunology. After a double, say, boosted or infected exposure to SARS-CoV-2, you get antibodies in the blood, and they can prevent actual infection if they are high enough. Ideally, with some vaccines, you get lifelong protection. So you get one vaccine, and you get years and years of protection from infection. And this is the holy grail of the immunization world, right? That you get one shot or a couple of shots, and then you never have to worry about that again. Of course, this is not what we've had now with COVID-19. We have far less than that. We have maybe 2 to 6 months, depending on when you're talking about and which variants you're talking about. But we're only getting 2 to 6 months of protection from actual infection, which, of course, we'd all like to see better than that. Now, what is good and where the vaccines have benefited us is with the memory B and T cells. So once you get the vaccination or infection now, you get your immune system makes memory B and T cells that eliminate the virus. And this is where the reductions in severity come. So it's because even though you get infected with SARS-CoV-2, you have this memory response that you've made to your vaccine or your previous infection. And that ramps up very quickly and can actually keep you from getting really sick. And that should last, we don't know yet because it's still just year 3 of this, but that should last for many years post-vaccination. This is the stuff that we're sort of looking at now to try to figure out how long we'll have protection from severe disease. And of course, I'll talk about it later, but I still think we hope we can have better vaccines too. This is how it works. So this is why, of course, people need to get boosted. When you get the immune system, when you get an exposure to an antigen, say a vaccine or a virus or a bacteria, you have a primary response. So this is your 14 to 28 days that we've all heard about for our vaccine intervals and stuff. You get a peak response after a couple of weeks. And then if you get later on, and notice the hatch marks here, this period between vaccinations can vary. This could be 2 infections year to year, or it could be 2 doses of a vaccine like you've seen with the COVID vaccines. But the point is, after a few weeks, or years, you have another exposure, so another vaccine, for example, you get a better response. So your secondary response is higher in magnitude. So you get a stronger response, but you also get a more focused response. So the antibodies that you make are actually a different kind that bind better, and you get a faster and more aggressive response. And that would keep going. So you'd see this waning of the immune response and then ramp back up every time you're exposed. Of course, this is relevant now because of the waning, right? The fact that we see, you know, the fact that we see people getting reinfected even as little as 2 months after their last infection or their last vaccination, the fact that people can still get infected is because we know these antibody levels do decrease. And that's unfortunate, but it's where we are right now with the situation we're in. Which means, of course, you can still get infected a few months after. But as I said, your immune response is still there. Although you got infected, you still have a immune response that will protect you from getting too sick. So I have to take a second just to talk about this because I think, we're always talking about silver linings and perks of the pandemic and different things. And there aren't many, of course, but there are a few. And I think if you're in science, the fact that we have RNA vaccines now used in human beings is probably one of the biggest scientific achievements that's come out of the pandemic. There had been research going into mRNA vaccines in the past, and they had been shown to work in animals and stuff, but there wasn't any real use within the human world. Because of the emergency situation we were in, these got emergency approval, and now we've seen that they're safe. And I should remind people here, ironically, right, the new vaccines that we were all kind of, that were got some criticism in the beginning are now the ones that are proving to be safer because the sort of old platform, the AstraZeneca vaccine, for example, the Johnson Johnson vaccines, these are sort of platforms that we've been using for years. Those are the ones that had these blood clot issues, remember? So it's actually the newer vaccines or the new types of vaccines that are proving to be safer. But essentially, it's the RNA. So it's the spike protein that's red triangle you see on the outside of the pictures of the virus we've seen. So it's the RNA that makes it. And our cells have lots of RNA, and we're used to dealing with that. But the RNA makes the spike protein, and then this is very complicated if you haven't studied immunology. But the simple explanation is basically when we respond, if our immune system responds to a virus. So if you have a virus infection shown here, for example, and the virus comes in, you get viral proteins made, and then the immune system takes those viral proteins, chews them up, and spits them out, and shows them to T cells, CD4 positive T cells that help make antibodies, CD8 positive T cells that kill virus-infected cells. What's really cool about these mRNA vaccines is they kind of trick the immune system into thinking that they are a virus. They are not a virus. They're a part of the virus. They're not infectious. They won't make you sick like a virus. But the cell thinks it's dealing with a virus, so it does the same thing it would do in a viral infection. It takes the protein, the spike protein that's made from the RNA in the vaccine, and it spits it up, chews it out, and shows it to T cells. So you get your CD8 and your CD4 positive T cells responding and making then your memory response. So in May of 2021, I got the opportunity to give grand rounds here in the Faculty of Medicine. And the question at the time was, will the vaccines end the pandemic? Because that was right after the ramp up of the vaccine rollout. And me being optimistic and glass half full like I am, I said yes. But I qualified it because I hoped the vaccines would end the pandemic, but I knew it was going to require a few things. So if everyone got vaccinated, and of course, we still don't have everyone vaccinated. Canada's done great, Newfoundland's done great, but there's still lots of people in the world who haven't been vaccinated. But the big ones, right? If the immunity didn't wane, and we already knew that there was waning of the immunity, it turned out to be even worse than we thought, right? These short intervals of protection from infection after vaccination. But we see that the immunity is waning. And of course, that would be if the vaccines could handle the other variants. And now we know they're not. This is why, of course, we're doing the updated vaccines now. So obviously, the vaccines didn't end the pandemic, and these are reasons why. Are they failing? So this is the question that came then, and the criticism of vaccines came up pretty quickly, that because people were getting infected, even though they were vaccinated, and some people still dying, even though they were vaccinated, some people thought this meant the vaccines were failing, and it depends on how you look at it, right? So if you look at infection, yes, people still get infected. But this graph, if you look at closely, this is from a website that I love. It's there below if you want to look at it. But it's basically a dashboard at Johns Hopkins where they track global cases. You can actually separate it by country. It's you can get lost in there for hours looking at the different trends in different countries. But what I want to point out here is on the top in the red is cases. So weekly cases right from the beginning of the pandemic up until now. And then below is deaths. And these numbers are very different, obviously. You're talking, 50,000 here, 200 here on these lines. But the trends are clear. So what I want to point out is if you look at the different waves, so the first, second, third wave, and this big peak here, of course, is the Omicron wave. So right around the end or the beginning of January 2022. What you notice is the peak of deaths was actually at the beginning of the globally. Sorry, this is just in Canada. Sorry, in Canada alone, and it looks the same in any vaccinated country. The peak of deaths was very early in the pandemic, and then we saw similar peaks of deaths as we saw increases in cases. But the big difference is when Omicron came, we saw this 5 times increase in cases, but we didn't see a similar 5 times increase in deaths. And that's partly, of course, due to the fact that Omicron was a milder variant, right? It wasn't killing people as aggressively as previous variants. But to get back to the vaccines, if you look here, this green arrow shows when we started vaccinating aggressively in around March, April in Canada of 2021. So if you look at the cases, so for example, from these two peaks, the cases were the same before and after the vaccine started to roll out, but the death rates are not. So right there, that difference in the death rates, which is about 3 or 4 times, about 3 times, is, in my opinion, the real benefit of the vaccines, that they were keeping people alive. You didn't see the same increase in deaths here as you saw with cases. So we know now that the vaccines, I definitely don't think they're failing. Do they prevent SARS-CoV-2 infection? Not as well as we'd like them to. The vaccines are not great at preventing actual virus infection as little as 3 months after your vaccinations or your last infection. Do they prevent severe disease? Yes, they are excellent at preventing severe disease. And this benefit could potentially be there for years. We don't know how long yet, but we will see, of course. And now we're seeing what we call hybrid immunity. So now we have people, most of us have been infected and we've been vaccinated. So we're actually seeing that hybrid immunity. So if you've been vaccinated in the past and then you get infected later, the immunity that you have from the combination is better than the immunity from either by themselves. So just vaccine or just being infected. So the current status of the pandemic, gathering is allowed. It starts to feel normal, right? Gathering is allowed, travel is ramped up, masks are no longer required in most places, vaccines are not being mandated anymore. Life does feel normal, right? But not for everyone. And if you ask some people, for example, Mr. Biden, he declared the pandemic over a few weeks ago. But he also said we still have a problem with COVID and we're still doing a lot of work on it. So, you can declare it over, but clearly the impact of the pandemic is not over. If you ask anybody on the front line, this is a tweet from a doctor who was working front line. To those who think that COVID-19 is over, an outbreak means I've been pressed into service as the standby family care provider. Hashtag COVID is not over. But of course, right away, keep the gravy train going. So people, social media is just toxic, right? You see, lots of individuals just, seeing things, the negative conversation, from people who I guess want this to be over. Accusations of everything, fraud, bribery, saying that, doctors don't want this to be over. Wish we had a vaccine for hypochondria. Time to lock up medical practitioners. I mean, the amount of foolishness that you see on social media about the pandemic is exhausting. So I thought, let's ask some people we know, people we trust. So here's Dr. Lisa Barrett, who got our MUNalum Tribute Award last week and was here to accept it. So I talked to Lisa last week and I said, what would you say if I said the pandemic is over? And we agreed that we'd say perhaps for some, yes. I mean, for some people, you've been infected once or twice, you've had 2, 3, 4 shots of vaccine, and you've had mild infections. It doesn't feel as any worse than a common cold. So for you, perhaps COVID is over, but not for everybody, right? I'll actually be interviewing Dr. Anthony Fauci in a couple of days, so maybe I'll ask him, but I think I know what he's going to say. That it's, like Lisa said, it's over for some, but not for everybody. And this is the this is that group I've been talking about for a long time, right? The vaccinated vulnerable, the people who've gotten vaccinated, hoping to protect themselves, but just don't have the immune systems to make the required response to the vaccine that will protect them from getting infected or getting very sick if they do get infected. So you're elderly and frail. We still need to watch this group closely. If cases rise in general, then, the more cases we have in the community, the more chance that somebody vulnerable gets exposed, right? I think we still have a lot of people in this province, for example, who have never been exposed to COVID or haven't been exposed enough to get infected because they've been lucky, because of the restrictions and the guidelines that were in place, they just never got exposed. Um, but now, with very few people masking and everything back to normal, there's a chance that people who may never have been exposed could get exposed. Immunocompromised people, due to the genetics, for example, people battling or recovering from cancer, anyone on treatment for autoimmunity could have a dampened immune system, and then not make the proper response to the vaccine or the virus. And recent data shows that only 40% of Canadians over 60 have actually had COVID yet. So, that tells me that there's still a lot of people out there who may have been vaccinated, but don't know what this infection is going to look like for them. And those are the people I'm worried about. They probably can't live normally yet because they may not respond or they may not be able to handle this infection. Good news, of course, there's improvements or updated vaccines are coming. So we already had the bivalent Moderna vaccine, which was a combination of the original Wuhan sequence, the original SARS-CoV-2 sequence, in combination with one of the newer Omicron variants, BA.1. So that was available a few weeks ago. And on Friday, so in Canada, on Friday, the Pfizer updated bivalent vaccine is now available as well, or will be available soon. So it was approved on Friday. And this has the BA.4, BA.5, which are the current circulating variants that are out there now, right? So the idea is that if you have those new variants in there, then the match between the vaccine and the variants that are circulating is better, and there's less differences between what you're getting vaccinated with versus what you might get exposed to, or the variant that you might get exposed to in the community. So hopefully those will give us longer protection from actual infection. And I'm sure they'll still give us the protection from severe disease. But we do have to wait and see. We don't know yet how effective these will be. We don't know if the 2 to 3 month window of protection from infection will be longer. I hope it will. It should be, with better matched vaccines. We might need to update these again because, as I said, there's already new variants, different variants, and variants of variants out there. Um, we've Many people have wondered why we kept the original Wuhan sequence in the vaccine, and it's probably a regulatory thing that you can't change it completely. But I think it's actually a good idea because we know that, for example, we had the Delta variant, and then we know that Omicron didn't come from Delta. So there's always a chance that another variant is still lurking out there, an older variant is still out there somewhere, and that you could get another version of Alpha, Beta, Gamma, or Delta come back. So I think it's an okay idea to keep some of the original strain in there. My optimistic hope is that as people continue to get boosted and as people get infected, reinfected, disease severity will continue to lessen. So as we build immunity, right, as individually we keep getting infected, unfortunately, with this virus, we'll have memory, more and more memory. And with that, I believe transmission will decrease at some point because the less severe your disease is, the less likely you should be to spread it. Of course, we know asymptomatic transmission can happen, but in general, it's people who are sneezing and coughing and symptomatic who are spreading virus. So if we're building up immunity and then we're contagious for shorter periods of time and we're less sick, then there should be lower transmission as time goes by. I believe that better vaccines might come. The fact that these aren't preventing infection that well for longer than a few months, we can do better than that, hopefully. We may never have a vaccine that you get once and you're never going to be infected with SARS-CoV-2, but at least we'd like to get 1 year protection out of it anyway. Antivirals, we haven't made a lot of progress. We've had remdesivir, Paxlovid looked like it was going to be a thing, but now it's not. It has a lot of cross-reactivity, say, with other therapies. The other one that came out, molnupiravir, that one, the data eventually didn't look as good as it originally looked, so that one's not getting as much use as we thought. But I know there's a lot of work going into what we call broad-spectrum antivirals. So the idea would be that we could have some drugs that would have antiviral activity against any RNA virus, for example. So in time, I think we will get better therapies. And hopefully, this virus will at least move into a seasonal schedule at some point. So we won't have these waves in the summer like we've had every few months. And at least we'd have a period of time where we shouldn't have to worry too much about it. But we'll see. So far, it hasn't moved into a seasonal schedule. Long term, unfortunately, this will happen again, right? This had been predicted. Anybody in the influenza world, for example, was sort of expecting another pandemic virus soon. We've seen them in the past. They can always pop up. New viruses will pop up, and we need to be more ready for that. And even here at Memorial, we need to be ready to study these viruses. So when SARS-CoV-2 was discovered, we jumped on it, of course, to study the immunity. Dr. Michael Grant, for example, has a couple of studies going in collaboration with myself and others to study the immune responses against this virus. But as a virologist, I wanted to grow the virus, so to actually test the virus in the lab. So we could study parts of it, but we couldn't actually study the virus. And new viruses will come up, and we need a level 3 containment facility here. So we are in the works, or we are in the process of trying to get a level 3 lab reestablished here at Memorial, and that will allow us to study viruses like this right away. And for example, test the immunity of Newfoundland and Labradorians against the viruses circulating right here in our own province. And that's it. I will end off on my always positive note. So it will get better, I hope. This is my one of a relatively recent shot of my lab. Last Halloween, actually, so not that recent, but we dressed as various parts of the pandemic. So antibodies, vaccines, and even some local politicians and public health individuals. Calvin has joined us since last year, so I have a picture of him in there as well. And this is my family. These are the people that bring me the most joy through all this. And I'll take any questions.
Okay, and we're back. And thank you so much, Dr. Russell, for taking the time to share your expertise on such an important topic that affects us all, regardless of where we live, regardless of where we are in the world or where we are in our lives. Just very quickly before we go to questions, I just want to remind our viewers that Manulife does offer new and supplemental life, health, and dental insurance for Memorial alumni and members of the Memorial community. So you can check that out on our website. And now it is time to go to questions. Now we don't actually have a ton of them right now, which amazes me. But we do have one. Oh, now they're starting to come in. They're starting to come in now. First one, though, Dr. Russell, is from Lorraine, and she's wondering, how long after infection can one get their next booster?
After infection, so that's been changing. I've seen 5 months mentioned. At one point, they were giving it in weeks. I think the answer to that will be on the public health websites, on the COVID-19 websites here in the province. But typically, it's you wait a few months, and I think that's partly because the assumption is that you're protected from your infection. So the fact that you got infected, it essentially is a boost to your immune system itself, right? So your antibodies would go back up, your T cells, B cells, they would ramp back up. So it's the virus, the infection is almost like a booster. So it would be a waste to boost right after that because you're basically already at your peak of immunity within, say, a month after your infection, unless you had a really, really mild case. But in general, it's 4 to 5 months after infection.
Okay, now here's a question from Renee, and she's wondering, this fall, would you recommend getting the usual yearly flu vaccine and put off the what is the word
Bivalent, yeah.
bivalent vaccine, or get the bivalent vaccine as soon as people are able to?
Get the bivalent vaccine because, we know cases are high right now. We know that there's lots of COVID in the community right now. So the likelihood of getting exposed to COVID is very immediate. Whereas the flu's not here yet. Usually doesn't peak or even start to ramp up until later in the fall. So I would say, you have to wait a few weeks in between getting them. So I would say get your bivalent vaccine as soon as you can, and then your flu shot after that.
Okay. And here is a question from Michael. You mentioned your optimistic hope. What is your realistic hope, particularly when you factor in newer variants like the growing concern around BQ1 and XBB?
Yeah, so I think, I mean, I think we're already seeing it, right? We anyone in this business, you know, people working infectious diseases, doctors working on this, researchers in immunology and virology, we expect this fall to be pretty busy with COVID because mask mandates are down. There's a bit of a double whammy going on here now, right? We will see lots of COVID. There's lots of variants, subvariants out there. It looks like these newer ones are even better at evading the current vaccine. So hopefully the new updated bivalent vaccines will handle them a bit better. But there's no doubt there's going to be lots of COVID in the community. And the problem with that, of course, is that where we don't have masks now, if you go back a year ago, there'd be, you might get COVID in your family and then everybody would isolate and miss work and kids would be out of school. But we had masks, so there was very little of everything else in the go. People stayed home when they had COVID. This year, I think it might actually be worse for just the the annoyances of disruptions of life because we also have all the other stuff, right? All the other common colds are back up, or going to be back up. And I've talked to a lot of colleagues and friends recently who have had non-COVID related respiratory infections. So there's, kids are out of school, people are missing work because of that. So I think it's going to be a busy 6 months, but we just have to live with it now.
Michelle Snow comments that this is a great presentation, Dr. Russell. She would like to know if you could talk a little bit more about any findings you have observed that may be unique here in Newfoundland and Labrador as compared to other parts of Canada or the world, or was the spread here very typical to other locations?
Oh, that's a good question. Um, I mean, as you know, right, we didn't have a lot of spread. We were doing a really good job at keeping COVID off the island, at least for a long time.
Mhm.
Omicron changed the game, right? Once Omicron came, we can all remember Dr. Fitzgerald saying, we're probably all going to get infected with this. And I agreed with her at the time, and I think it's proof now, right? We've had a lot of people get infected. So I wouldn't say there's anything unique about the province, except for the fact that we had so long where we didn't have any cases. One unique thing that will be interesting to study going forward is the fact that we almost had a complete break in variants, say. So, for example, when Delta was around, some people in the province had Delta, but our caseload was pretty low. And then all of a sudden there was Omicron. So if you look immunologically or virologically, you almost have two groups of people who had Omicron, and then people who had something before that. By now, of course, everybody's getting Omicron, but some people will only have had Omicron because they didn't get it before that. That's one unique thing. Other than that, it's been pretty much the same as the rest of the country in North America.
We've had a couple of comments in terms of the God, I have a hard time saying that word. Bi,
Valent. Yeah.
bivalent, the bivalent vaccine and the flu vaccine. Did not, Roberta is in the US and she says we are offered the flu and the bivalent COVID vaccine at the same time day. And she just got
Okay.
herself that today. And Michael Barber is also concurring with that. He's in California and he got both at the same time, one in each arm. So that's interesting.
That's a good point, right? And that's not unheard of. I mean, if you think about the MMR vaccine, right? It's actually, measles, mumps, and rubella. So it's not, we've been doing that for years, right? There's lots of cases where we give two or three different things. When you take your children to get their shots, they're often given 2 or 3 different vaccines the same day. And the immune system is so specific that it says, okay, that's a car and that's a truck and that's a boat. And it can recognize these variants or these viruses as completely different things. And there's enough energy in our immune system to handle 2 or 3 different things at the same time. Um, in Canada, we're always a little more conservative than in the U.S. I'm not surprised that the U.S. is going, aggressively giving both at the same time, because it makes sense, right? You're trying to keep the healthcare system from getting overloaded, so you want to prevent both, as fast as you can. There's nothing wrong with that. I believe that we could be vaccinating influenza and COVID-19 at the same time because our immune systems can handle both at the same time. But where we haven't had that many years of dealing with COVID, and where we've already seen, that the waning of the immune system happens, it's not surprising that Canada said, okay, let's separate them a little bit just to hopefully allow your immune system to make an optimal response against one before it has to deal with the other.
Yeah.
But I honestly don't think it really makes a big
Yeah.
difference.
Well, we do have a couple of comments here that apparently Cheryl Perkins says that the NL public health nurse told me that they'd be doing both jabs at once the flu shot arrived.
Oh,
And
okay.
yeah, so there you go. I mean,
See?
things are changing all the time. They're changing right now
Yep.
within the
Your
last.
info is out of date by the time you finish your
That's
presentation.
right,
I'm used to
exactly.
that.
Exactly. We do have a question. I mean, I know you mentioned masks earlier, and feel free to, you could defer answering this, but Tony's wondering, what is your opinion on the use and utility of masking in various places, such as grocery stores, etc.? And do you consider the risk of eating in public to be low, medium, or high?
I believe masks work. And I believe that because, while we were masking, we saw very little, you know, sort of the control in the whole thing, right? While we were dealing with COVID, the other stuff wasn't around. So all the other normal respiratory infections, flu, for example, the fact that we were masking, I think kept all those things or contributed to all those things being lower than usual. I mean, we had, last year, the year before, we had no cases of influenza in the province. And that had to be in part due to the fact that we're masking. Of course, distancing made a difference too. So I firmly believe the masks help. And every time mask mandates came down, we saw rises in cases of COVID and everything else, right? So there's no doubt they have a positive benefit in containing things. To the second part, I think the risk is high right now. Eating in public, you know, depends on how close you are, right? If you're in
Mhm.
a spaced out restaurant, maybe not. But most of the restaurants and bars, you're not that far. You're 6 feet or less than 6 feet from others. So I think the community caseloads are high right now. So I would say that eating in restaurants is, definitely a risk for getting COVID right now.
Yeah. This is sort of a mask related question. Dale is saying no one in his family or her family has had COVID and they've all had their eligible vaccines, but they are all still masking. So they're asking, is that useful? I suppose so.
If your goal is to not get infected, and if you have people, if you're working in a long-term care facility, if there's any chance that you could get infected and get sick yourself or make somebody else sick, there's of course there's benefit in wearing that mask. It definitely helps. You know, I think the question is, are you going to wear a mask forever? Because I think it's very clear now. It was clear from the beginning that this virus wasn't going to go away anytime soon. It's I think best case scenario at some point is that we'll kind of be living with 2 flus. So hopefully that there will be seasonal aspect to this where you won't have to worry about it at all in the summer. But this virus now may be around for a long time, and there are going to be people. I think you're already seeing it, right? If you go to a grocery store, most of the older people, most of the elderly people are masking, and most people, are not. So, and I think unfortunately that was always what I envisioned as the new normal, that some people were going to have to be more careful than others,
Mhm.
because this virus is not going away, and not everybody's making a great response to the vaccine, and we don't have great drugs right now for people who get infected and can't handle it themselves.
Mhm. And some people are more vulnerable than others. It's as simple as that.
Sure.
Yeah.
Yeah.
Here's a question from Emily Lamb, and It's an interesting one. She says, "Is it not important to distinguish between the pandemic being over and people being over the pandemic?" How would you answer
I
that
think you've
one?
hit the nail on the head, right? It's,
Yeah,
is the pandemic, if you ask the question, right, is the pandemic over? No, the pandemic's not over. Are you over the pandemic? Many people are over the pandemic.
yeah,
But, you know, uh, that's almost a luxury, right? You know, I had COVID and I didn't get that sick. I'm not afraid to get COVID now. Now, am I still being careful? Yes. My our little girls still have, five grandparents who are not as young as me. So, we don't want to make them sick. And, we're going to be careful if we think we need to. If caseloads are high or anybody's got symptoms, then we may wear a mask, in Christmas or at a birthday party. Who knows? So, yeah, there's a lot of people who are finished with this, but again, we we have two groups now, right? People who don't need to worry about it and people who do. And I think that's why I say the pandemic is not over because there's still a lot of people who have not been exposed and could get very sick if they get it. So 3 years from now, maybe we will have all been exposed and everybody will know that they can handle it. But I think we're still at a very critical time where there's people who could be exposed and get very sick. And it's that those are the people I've been worried about for a long time.
hmm Um, the question from Megan, what are your thoughts on the understanding of the virus, well, and long COVID? I mean, how much do we know about that right now?
I don't know. Long COVID is still a mystery. We it's important to separate something with long COVID. So there's always been a long syndrome aspect to respiratory infections, right? Most people get a respiratory infection and they clear it. But I recently had, long COVID that wasn't COVID, for lack of a better description. I had a respiratory infection, and then for months I had this tickly cough that drove me crazy, and I coughed that hard that I think I actually pulled a muscle in my ribs. It wasn't COVID. Um, and it wasn't, it didn't fit the description of long COVID. So there are respiratory sort of syndromes that have always been around. But some people, of course, get COVID and have this textbook definition now of all these symptoms, the fatigue, the not being able to sleep, the insomnia. We still don't know. I mean, one theory, of course, is that the virus, if you're infected long enough, if you don't resolve the infection quickly, that the virus can get into your brain and affect your brain. Um, there's there's theories that the virus changes your lungs enough that you can't your breathing and things are affected longer. But the answer is we don't know yet who's going to get long COVID. In general, the mild people who get milder infection have a lower chance of getting long COVID, but long COVID is probably the top thing on most people's mind right now is figuring out if you could predict who was going to get it. So if you could look at the original, while you had COVID, if we can find some way to say, okay, you've got this set of symptoms or this aspect of infection, and that's a predictor for long COVID. But then how to manage it is a whole other story.
Um, Here's a question from Angela. How soon after possible COVID exposure can one expect that they might be infected? Early on in the pandemic, it was about 2 weeks, she thinks or writes. Has this changed?
Yeah, I think that 2 weeks originally was more like we expected most people to be resolved within 2 weeks. Some people did show symptoms later, but at this point, it's more, as the variants, as the new variants came up, we saw that interval shortening and shortening. So by now, it's more like 3 to 5 days usually. And if you look in households, for example, where you get your index cases, right, where one person gets COVID, and then if they spread it to people within their household, it's usually 3 or 4 days after the first person tested positive that the next person tests positive. So I think it's about 3 to 4 days right now for most people.
Okay. Heather Hopkins is wondering, do those who are unvaccinated get sicker with COVID than those who have been vaccinated?
That's a tough one to answer because there's always exceptions, right? I mean, you could say people in the 20 to 30-year age group don't get as sick as people in the 50 to 60-year age group, but there's always exceptions. So in general, yes, unvaccinated people have more severe disease than vaccinated, but at this point now, um, there's exceptions, right? You can't say that for everyone for sure because some unvaccinated people had very mild cases even back when we had, the nastier Delta on the go. But then we've also seen, young people who were vaccinated get pretty sick and be in bed for a week with this. So there's an aspect that we don't know yet. And this is probably my biggest curiosity right now is what really predicts, how sick somebody gets, because that's really the problem, right? If we could predict how sick someone's going to get based on any marker or any indicator, that would be great. Because, like I said, in general, younger people don't get that sick. But everyone knows a young person who got really sick. In general, older people get sicker. But I know 75-year-old people, who had really mild cases, vaccinated or unvaccinated. So there's an aspect there that we don't understand yet.
Right. We do have a few more questions, and I know that we asked you ahead of time if you had enough time to stay to answer those questions. So we're going to keep going. So we'll
Sure.
probably finish, I think, probably around 5 after 2. But here's one from Michael Barber, which is interesting. He's asking, there is much made in the media, in some media here in the US, about the fact that the unvaccinated in the developed world are the main cause for all these variants, but others indicate that it is due to the lack of vaccination in the underdeveloped world. Is there a correct, or where is the truth in that, or what are your thoughts on that?
That's a tough one. I mean, the basis of that discussion comes from the idea that the more the virus replicates, the more chance it has to mutate, right? And there's no doubt about that. I can reproduce that in a petri dish in the lab, right? If viruses mutate, they do that. That's what they do. They're good at that. That's how they maintain diversity. That's how they've survived as long as they have. So there's no doubt that if you look then in an individual human, then for example, if you've got immunity from a vaccine, for example, then theoretically the virus shouldn't replicate. And we saw that pretty clearly, pretty early. People who were vaccinated, the levels of virus didn't get as high, and they weren't sick for as long, and they weren't as contagious for as long. Again, in general, not everybody, because some people didn't respond to the vaccines at all. But in general, yes, people who were vaccinated, the virus theoretically would have less chance to mutate. So then that sort of turned into that argument that, well, it's the unvaccinated people who were generating the variants. Of course I'm pro-vaccine, but I think that's a hard argument to make, right? Because who can go back and say Delta came from this person who was unvaccinated? We'll never know these things.
Mhm.
But, mathematical modeling, scientific prediction will say that the more we let the virus replicate unchecked, the more chance we have of getting new variants. So in that case, it's, anybody who, but the problem with that argument is you could say, well, elderly people who don't make good responses to the vaccines are also great incubators for variants. So to me, I don't think that's something that you can never assign cause and effect
Mhm.
with a case like that, right?
Mhm. We've got a question here from Ainsley Hawthorne, and she's asking, her question is, you mentioned that once you've had COVID, you know how you'll respond to the virus. But I know some people who have had more serious reactions the second time they caught it than the first. Do you
Yep.
think past infections are a good predictor of how you'll react to the virus in the future?
Yeah. So another good question, right? They're all good questions, of course.
Hmm.
But that one, I mean, the idea, you would think, right? So let's say you got vaccinated, and this is what I've been saying for a long time, but I'm starting to wonder myself now, to be honest, because, let's say you get vaccinated and you make your immune response to the spike protein, and then you get infected, unfortunately. We all will, I believe that. But then you see the whole virus. Your immune system sees not just the spike protein, it sees the whole virus, and it makes an immune response to all parts of the virus. So you actually get a broader response then, and then that's a booster of the vaccinations that you had. So I would think, I've always thought that your first infection would be your worst one, and that you have a stronger memory response then ready for the second time. Now, and that should be the case, right? That's textbook immunology. But that's based on the assumption that the exposure is exactly the same. So we have different variants is the problem. So I think what maybe, and I'm seeing this myself just in social media right now, but a lot of my own friends have said, oh, the second one was worse than the first, which was
Hmm.
against my theory and against the immunology, textbooks would say. And I can only assume that it's because the variants are better at evading the immune response. So even though you're infected and you've made a good response against your vaccine and your previous infection, perhaps because these new subvariants of Omicron have changed so much that the immune response you made against the first infection is not that active or that effective against the new subvariant. But again, I think that um, the new bivalent vaccine should help with that.
Okay. And I think this might be our last question. What do you believe is missing from our current public health measures? What should our priority be in the future?
Oh, that's a good one. So I'm not a public health expert, even though I play one on TV. Um, I don't know. I don't think anything's missing. I think we did. I mean, this province responded, like no other place, right? We did everything we could. We did lockdowns, we did mask mandates, we did vaccines. We did everything we could do. And the problem is, it's impossible to predict, right? This goes back to one of my first slides. We don't know where the next threat will come from. So all we can do, I mean, we've learned a lot. We could give a full presentation on what we learned
Mhm.
public health wise, about
That'll
public
be
health
your next
opinion.
one. You can come back and do that one.
No, no, no. Get somebody from public health who actually knows public health.
Okay.
But yeah, I think we've done everything we could do. Some would say we did too much, right? So I think all we can do is be ready, right? So, for example, again, I would like to see a level 3 facility here. There, we could, grow these viruses right here. The isolates that were circulating within our own province, for example, would have been great to get those into a lab and see if for example, when Delta showed up, if we could get blood from vaccinated individuals, say, oh, look, the vaccines will work against Delta because we've tested it in the lab. So, being able to do things faster, right here at home will be better. But as far as preparedness, all you can do is, I guess the biggest thing that's come out of all this is that we've done this now, right? We've gone through a pandemic and we know how to isolate, we know
Mhm.
how to distance, we know how to work from home, we know how to, implement mask mandates and things like that. And people know how to just make these choices on their own. So I think we've learned a lot and we're already ready for the next one, bit more ready. But I don't, I can't think of anything that's missing. But now my public health colleagues, maybe they have a great list of what we should have, and I would ask them.
Okay, we will ask them. I would like to really sincerely thank Dr. Russell for sharing his time and expertise with us. This has been a fascinating hour, and we like to thank all of you that joined us and thank you for your great questions. And if you enjoyed today's event, please don't forget to check out our alumni website for upcoming events, including a special Coastlines Book Club with Lisa Moore on October the 27th, and an upcoming MUNalum 101 on November 15th, which will focus on the role of nurse practitioners in the future healthcare. So that is interesting. And as I indicated earlier, this session has been recorded, and I will be sharing a link in a follow-up email. So please keep your eyes on your inbox and share it widely. And I hope everyone enjoys the rest of their day. Thanks again. Thanks again, Dr.
Thank you.
Russell.
Thanks for having me.